Hello and good morning everyone. We are Group 7 from Communication Principles Session 8. We are going to share some basic knowledge under Mission 3. First, we are going to talk about digital fixed-line telephony. Digital fixed-line telephony is a type of telephone line that carries voice or signals through digital sampling. In the early 90s, telecommunication networks is changing towards digital world. The transmission line and switching has been using digital signals in their operation align with the rapid advancement in VLSI and microprocessor field. Information signals must converted to digital form before it can be transmitted. In a digital audio, two or more voice signals can be transmitted simultaneously over a single physical medium or connection. Digital switching enable the reduction in the amount of copper cables between exchanges. Here we have some fundamental principles or techniques that require full coding of the original signal used. First we have pulse code modulation, PCM, which converts analog signals to digital, which enables the voice to be transported over a digital trunk and used to digitally represent sampled analog signals. On the other hand, we also have digital multiplexing, which is a process of transmitting two or more signals simultaneously. There are several multiplexing methods we are using: frequency division multiplexing, FDM, and time division multiplexing, TDM. Before we get into encoding voice by pulse code modulation, let us discuss some of the terms that help us understand more about the PCM. Firstly, let's talk about the frequency range of the telephony. The frequency band, in context of analog to digital encoding, defines the range of frequencies that are selected for conversion to digital. Human ear can hear frequencies from as low as 20 Hz to as high as 20 kHz. In telephony, the usable voice frequency band is sampled at a range of approximately 300 to 3400 Hz, where the voice frequency is equal to 3.1 kHz, designated by the International Telecommunications Union. Next, we have the sample rate. Sample rate is the number of samples of audio taken per second, measured in Hz or kilohertz. In digital encoding, the goal is to optimize the sample rate by making it as low as possible while still maintaining a reasonable digital reproduction of the voice. Hence, we have a sampling theorem, or known as the Nyquist theorem, which was established by Harry Nyquist, a Swedish-born American electronic engineer. It is defined as a relationship between sample rate and frequency bandwidth. A way to digitally encode an analog signal using ones and zeros. The sample rate needs to be at least twice the maximum frequency bandwidth. For example, 4 kHz of maximum frequency bandwidth need to have at least 8 kHz of sample rate. Lastly, we have bit rate and bit depth. In digital audio, using PCM, bit depth is defined as the number of bits of information in each sample. In other words, it is the resolution of each sample. Bit rate is the number of bits transferred per second. Following we have the quantization, which is a process encoding a sample of audio to digital by estimating the sampled amplitude into a value suitable for coding. The analog signal at the receiving end obtained through decoding of digital signal won't be exactly the same. This difference between original signal and processed signal is known as quantization error. Now, let us talk about how we encoding voice by pulse code modulation. At first, we must limit the voice band to 300 to 3400 Hz in telephony. After that, we sample the signal at least at Nyquist rate, which is twice the bandwidth, to avoid aliasing. In this case, sample rate should be 8000 times per second. Let's say we use 8 bits to describe the signal, means that we have 8000 multiples with 8 bits, which is equivalent to 64,000 bits per second for each voice channel. In general, to represent an analog signal in terms of digital words, it constitutes 3 processes. First, sampling the analog signal. Second, quantization of the amplitude of the sampled signal. Third, coding the quantized sample into a digital signal. With pulse code modulation, we can represent our sampled analog signal in digital form. Moving to our next topic, digital multiplexing. For the digital phone line telephony, we don't use frequency division multiplexing, even though the numbers of calls can be increased, but we need to replace existing unshielded twisted pair cables with coaxial cables to get enough calls on a trunk. With time division multiplexing, we can synchronize switches at either end of the cable and put multiple digital signals over a single physical connection. However, this only works in digital signals, so all signals must be in digital form. Besides, we need to define a suitable bitrate for each voice channel if we want to enable multiple calls to be transmitted at the same time. These are the recent advancements in telecommunications and its benefits. Internet of Things, IoT, leads to an exponential growth in connected devices. It also eases the access of information in real time regardless of your location, boosting the flexibility in workspace. Able to perform multiple tasks, increase capacities and save time. Artificial intelligence, AI, substitute human intelligence in the performance of tasks. Drives down the time taken to perform complex tasks with higher precision and higher efficiency. 5G. Significantly improved the data speed and mobile voice services. Reducing time in transferring large-size data helps to save time and cost. It is an evolution of the network which brings enhancement as well as boosting the performance in telecommunication. Here are some of the common misconceptions on digital communication. First, misconceptions in terms of health. Many people think that the radiation of cell phones is harmful to humans and eventually causes cancer. People are concerned that cell phones emit radiation that might have the potential to cause certain types of cancer or other health problems. But what people don't know is that cell phones emit radiation in the radio frequency region that falls into the non-ionizing range of the spectrum, which is low frequency and low energy. The energy is too low to damage DNA. By contrast, ionizing radiation, which includes X-rays, radon, and cosmic rays, is high frequency and high energy. Energy from ionizing radiation can damage DNA. DNA damage can cause changes to genes that may increase the risk of cancer. Lastly, we have misconceptions in terms of cybersecurity-related issues. Most people think that wireless networks are not safe. But the truth is a properly secured wireless router is adequate for all but the most high security needs. For the average household, Wi-Fi is more than fine, and any network with a secure password and WPA2 with AES encryption are going to be more than adequate. Intrusions into a home Wi-Fi network are rarely caused by actual brute force breaches. The most common cause? Weak and predictable passwords. At the end, thank you for your cooperation, and we have a little game to test your understanding on digital fixed-line telephony. Now you may start the Ericsson Tech Traveler game Mission 3. Have a good day.